If you're here, you're probably here to learn statistics or use statistics. That's what we do here at Intuitive Bayes. We create courses that teach you how to learn stats and how to apply stats in the real world. But do you need to buy an Intuitive Bayes course to learn statistics? The answer is absolutely not. There is lots of great material out there to both learn statistics and learn how to apply statistics in your own settings. The newest one of these tools, though, is large language models, notably Bard and ChatGPT. So a question we've been getting is, are these tools useful for the Bayesian learner or the Bayesian practitioner? And the answer is absolutely yes. So let's talk through it, taking the two mindsets, the learner mindset and then the practitioner mindset. Let's start with the learner mindset. As a learner, you're going to be learning about the theory of things, like what a prior is, what a posterior is, and how these concepts connect together. You also will be trying to build pretty simple models to test your understanding and apply the concepts that you're learning. So let's talk through how you can use ChatGPT to do that. So what I did is I went to ChatGPT and I asked it open-ended questions. And to be honest, it did really great with these prompts. When I asked it things like the difference between likelihood and prior, it provided a great explanation that was quite correct. I asked it other things like building simple examples that I could use to test my understanding, and it again did really good here. It even did quite well on more esoteric questions, such as the difference between model comparison methods. In this case, we asked ChatGPT to provide an explanation between AIC and WAIC and what the differences were, and it did a great job, even providing some great context. Where it faltered is when I started asking it domain-specific questions. So I asked it a question of how I can use Bayes' theorem with building composite materials. This is something that I've done when I've blended my expertise in mechanical engineering with Bayes' theorem. On this prompt, it didn't do so great. It mixed up some ideas, such as the percentage composition of materials and the percentage as it's represented in probability. So when it comes to mixing statistics ideas with specific domains, it seems to have some trouble there. But this is a very narrow use case, right? The Venn diagram of Bayesian statistics and any particular subfield. Another thing I did was ask it to build me basic models. And in this task, it also excelled. This was great because I could describe a model to ChatGPT and it produced a model that would just run. So as a learner, as you come up with these ideas and want to see examples, this is a really good resource to generate training examples for yourself. So you can think of ways to describe simple distributional models or linear models, and you can build examples to reinforce your own learning. Here's an example of a distributional model, and here's an example of a linear model. Here's the downside, though, of using these large language models, and it's as a learner, you don't know the optimal learning path for you to go down. You can ask as many prompts as you want in any order, and it will just explain them, but then you may end up learning concepts out of order. So you may be trying to learn about posterior predictives before you actually understand what a posterior or a prior is. So my recommendation is pair these large language models with expert resources. This way, you can use the expert resources to provide the scaffolding in the order of things you should learn, and then you can also verify the answers that the large language models are giving you with those expert resources. So where you need to dive in further or where you may have some additional questions, then you can go to the large language model, ask your question, and get some additional context and information to keep moving you forward and getting you past sticking points. Now, the goal of learning is to eventually put these ideas into practice. And so another question comes up. As a practitioner, are large language models useful to me? And the answer here is yes as well, though there are some caveats. As a practitioner, I asked it to build me more complex models than what a normal beginner would have. So as we've covered, these large language models did really well with basic models and linear regressions and models that we see over and over again. What I then asked is for ChatGPT to create me a spline regression, so one step up from a linear regression. It generally did pretty well, but some of the answers included methods that didn't exist in PyMC. So as a practitioner, you'll have to take these code examples, paste them into your editor, and then run them to see what happens. I haven't shown this here as well, but you can also do this in GitHub Copilot, where you describe your model and GitHub Copilot will expand it. Coming back to just ChatGPT though, I asked it for some examples of hierarchical models. And something to know is these large language models, like Bayesian statistics, are stochastic. So in some cases, it did pretty well. This one, it missed the prompt a little bit because it didn't give me a linear model. It gave me a distributional model, which of course may be linear, but we wanted some slopes and coefficients. So when you ask it to correct itself, it did pretty good, but it does some weird stuff, like it added the hyperparameter beta 1 into the group level here at beta 1 species. So a subtle mistake. At first glance, it looked correct, but then I noticed this one tiny mistake. So another thing to note as a practitioner is currently ChatGPT's training set is out of date. A lot of the models I'm getting are from PyMC 3, and similarly for other PPLs are out of date versions of them. For PyMC 3, I asked it to give me a PyMC v5 model, and it was unable to do so. And also, this is one of the areas where I saw the faults or hallucinations, as they're called. It explained that PyMC v4 was going to be based on PyTorch, when in fact it was going to be based on TensorFlow probability. Now, this is ancient history, but as a practitioner, this knowledge actually is not helpful because it's either hallucination and leading me off track. What I really wish was it was just able to give me a PyMC v5 model in the latest API. But as you can imagine, these models are getting updated frequently, and I anticipate that it will soon have v5 examples. But it does highlight a flaw, is that I don't know whether these large language models will ever be able to produce models on cutting edge APIs, because it takes time for that text to come out on the internet or training sets for the large language models themselves. And as a cutting edge practitioner, you may be needing to use some of these newer features before a large language model can teach them to you. So here are my practical tips if you're a practitioner. Most of the default models are pretty good. They're subtly off though, so when you use them, you're going to have to verify that they're correct. If you're using PyMC, you can use the print model graph function to see what the model looks like as a visual graph, and then you can debug any issues that way. If you're looking for the latest API though, and you want to use the newest features such as jack sampling, which is new to PyMC v5, large language models right now are not quite as helpful, but they certainly get you set up with the basic structure, and then you can update your model from there. So at Intuitive Bayes, we always have a section recap, and it'll be no different here. In this case, we're going to recap how you can use large language models both as a learner and as a practitioner. As a learner, we advise you to pair these large language models with an expert resource, whether that be a book, a YouTube series, or an Intuitive Bayes course. Use that expert resource to see the order in which you should learn concepts, and use a large language model to reinforce your learning with generated training examples or to supplement the material where you may be confused. You can also use a large language model as a learner to generate basic models, so when you have an idea in your head, you can see what that would look like in applied code. As a practitioner, large language models are good at producing scaffolding for more complex models. In my experience, they get them mostly correct, but often make subtle mistakes. So you can use it to start a large model and then edit mistakes where they occur. The use case they struggle on, though, is with the newer API. So with that, you're going to have to go to the docs for the package or read blog posts or learn in the traditional ways. But still, large language models are a good way to get started with a larger model, and then you can replace pieces of functionality without having to write the whole model yourself. With that, whether you're a learner or a practitioner, I hope you've learned a couple of different ways in which you can now use large language models to supercharge your learning or your ability to produce Bayesian outputs. As we always like to say at Intuitive Bayes, Pyam cheers, and let's keep on sampling.